Hi, in this lecture I'm going to continue on with the example that I've been working on and add some new functionality to it. And I'm going to add functionality by using decision logic. So if you recall, JavaScript is an imperative programming language, and with imperative programming languages, the programmer has to describe step by step how to solve the problem. And in solving the problem, there are three control of flow structures that are available to work with. One being sequence, which is the default flow of control structure, and that just means that the statements execute in the order in which they occur in the program file. So statement 1 would execute, followed by statement 2, followed by statement 3, and so forth. But along with that default flow of control structure, there are two other options available. One is decision control of flow logic. The other one is iteration control of flow logic. And so we're going to focus on decision logic now. So what will happen in the example that we're going to look at is we'll still get user input for either Fahrenheit or Celsius. We will still call up our functions and do the calculations, except after the calculation is performed, the program will then examine the calculated value, and depending upon what that value is, it will take it'll make a decision, and will take some course of action based upon the decision that's being made. Okay, so that'll, I think, be clear here in a moment. But before I even get into the coding details, what I want to do is take a look at flowcharts. And flowcharts are something that can be used to graphically describe processes. They're used in computer science, and they're also used in some other disciplines. So even if you never take another computer science class, there's a chance that you might in the future encounter flowcharts, and so an understanding of how they work and the basic symbols that they use and so forth will be helpful to you. Fairly certain it's good background knowledge that you will use at some point in time in the future. Okay, so I know that when I was in college I took management science classes, and some of the processes that we examined there were depicted in flowcharts. My wife's a registered nurse and has to do some certifications for her job, and the technical manuals that she uses are laid out in flowchart form, so I'm fairly certain that you'll see this if you haven't already seen it in the past. Okay, so first off, let me just describe the basic symbols that are used. And there are 6 basic symbols that are used in constructing flowcharts. One is an oval symbol known as a terminal symbol, and in a properly drawn flowchart there will be 2 terminal symbols, one at the very beginning and one at the very end. And the one at the beginning, it will be labeled with the keyword start, and the one at the end will be labeled with the keyword stop. Okay, so it should be pretty obvious what that does. It does it just as the user is interpreting this graphical representation of a process. This gives them a reference point from which to begin, and the other terminal symbol alerts them that the process is ending at this point. Now, along the way, step by step, we point to the next step with what are called flow lines. Okay, so in a properly drawn flowchart, we'll have 4 possibilities for flow lines. You'll either have a flow line with an arrow leading down, or a flow line with an arrow leading up, or you'll have a flow line with the arrow drawn to the left or to the right. So we don't use curved lines or anything. We'll use vertical and horizontal lines in constructing these. And again, the idea of the flow line is that just takes us to the next step. It lets us see the order in which the steps occur. And so that's a second symbol that's used. A third symbol that's used is a parallelogram, and where a parallelogram is used, it typically suggests either input or output at that step. So if I want to show the program receiving data from the user at some step along the way, likely I would show that with a parallelogram. Or if I want to see, if I want to show a point at which the program alerts the user of something, maybe through an alert statement or something like that, I'd use a parallelogram to depict that. Yet another symbol that's used is a rectangle, and that roughly corresponds with an assignment statement. So this would represent typically some calculation, some expression being resolved, and then the resulting value being put in some memory location. So again, this is, in at least the programming context, is going to correspond very closely with an assignment statement. Then we get to the symbol that is of particular importance in the examples that I'm going to go through in this lecture, and that's the diamond symbol, which represents a decision point. And with a properly drawn flowchart, every decision point should be associated with 3 flow lines. A flow line leading into it from the previous step, and then at that decision point, a Boolean or true-false decision will be made. Okay, so Boolean means true-false. So there will be an evaluation. An evaluation will occur here, and that evaluation will result in some true-false outcome. And so we have a flow in the event that the outcome is false, and we have another flow in the if the outcome is true. Okay, and we'll either take the true path or the false path. Now, that is the basic collection of symbols, and I realize I told you there were 6, but I've only shown you 5. There's one other symbol that I have not shown you, and that symbol, I'll just for completeness, I'll tell you about it. So if I go over here to the drawing tools, I had the hardest time drawing these diagrams today in this new version of Word. It was so hard to draw horizontal and vertical lines. It kept wanting to angle them off. So I apologize for these, drawings looking so crude, but had my problems. If I choose to do so, I can also use a 6th symbol in a flowchart called a connector symbol. And that connector symbol will, I'm going to swap something out right now. That connector symbol will appear like this. Okay, and so you'll notice that if I am about to run off the page and I still have more of my diagram to draw, then what I can do is throw in a circle known as the connector symbol, draw a flow line leading into it, and then draw that symbol elsewhere. I'm going to get real fancy here with this. So I'll repeat the symbol elsewhere, probably on a new page, and continue the diagram. Okay, so the connector symbol doesn't really communicate any logic regarding the process. but what it does is allows the diagram to be continued elsewhere. And the standard convention is that the first occurrence of a connector is labeled A. The second, if this diagram spans 3 pages, you might have to use a second connector symbol. It would be labeled B and so forth. Use them as you need to. And anywhere you use a connector symbol, it'll actually be used twice, initially with a flow line leading into it, and then wherever you resume, it'll show up again with a flow line leading out of it. So a connector symbol is really just used to physically organize the diagram if you run out of space. Okay, so I'm going to leave that the way it is, and now we're going to come back and take a look at how flowcharts are actually used to solve a particular problem. All right, so I think I'll switch off here real quickly. No, I won't. I'll go ahead and show you the diagram, then we'll come back and look at the program code. Let's take a look at the program code later on. I'm describing a process here where I'm receiving a Celsius value. Okay, so I'm going to use a one-way decision. I'm going to be eventually implementing this in JavaScript with a if statement, and I'm going to do the calculation, get the input, do the calculation, and then once I do the calculation, if the calculated value is within some numeric range, namely if it's less than 32, then I'm going to output a string value cold, and I'm also going to change the color of the text box in which I display the string value. And that'll be demonstrated here momentarily in the actual JavaScript code. But logically, here is what would happen if I followed this flowchart. I would begin, I would get somehow a numeric value that represents my Celsius value. I would perform the computation. Okay, so I'm not going into great detail showing the formula. I'm just saying I'm going to calculate the Fahrenheit value based on the Celsius input. And then once I calculate that value, I'm going to make a decision. If that calculated value is less than or equal to 32, then this expression will evaluate true. If it's greater than 32, the expression will evaluate false. So again, a Boolean expression can only evaluate true or false. And let's pretend that I put in a Celsius value and convert it to Fahrenheit, and that Fahrenheit value is in fact less than 32. Then it would take the true path and ignore the false path, and it would assign to some display element, probably a text box. It would assign to some display element on the form the string value cold, and then it would continue to the next step and also change the background color of the display element where it has previously assigned the string value cold. And then once it has assigned string value cold, changed the background color, it would continue to follow the flow line, and that flow line would eventually take it to this connector symbol. And when it reaches the connector symbol, elsewhere, it would tell the process to stop. So in the event that it receives input and calculates a value less than or equal to 32, it takes the true path, displays cold, changes the back color of the display element, and essentially ends at that point. On the other hand, if it receives a Celsius value that is then used in a calculation and calculates a Fahrenheit value that is greater than 32, then this Boolean expression evaluates false, and it would ignore the true path and instead take the false path, and when it takes the false path, it does nothing. That's the characteristics of a one-way decision structure. in a one-way decision structure, there is one do something, meaningful path, and the other path is a do nothing path. So you make a decision. If the decision evaluates true, do something. Otherwise, do nothing. That's the one-way decision logic. And that's implemented in JavaScript using something called an if statement. Okay, so we'll look at the code here momentarily, but if I want to make the kind of decision where if I perform a test and it evaluates true, I want to do something, otherwise I don't want to do anything, that's one-way decision logic. Let's take a look at an alternative, the two-way decision structure. And you're going to have to do this as part of your assignment. Okay? So the two-way decision structure is very similar to one-way. It uses in JavaScript the if-else statement, and we'll analyze the way it works through this diagram. And again, you can then write the program code yourself. But we would start here with the diagram's terminal symbol. We would get the input somehow from the user, and then we would perform the calculation. So the first three steps in the diagram look the same as they did before. Then we would reach our decision point and again make some kind of true-false decision. And in this case, we would be checking to see, same thing, whether or not the calculated Fahrenheit value is less than 32. And if it is less than 32, we would take the true path and assign cold and change the back color to blue, which is exactly the same thing that we did before. On the other hand, if the calculated value is not less than or equal to 32, we would take the false path, and this time it's different than it was previously. Instead of doing nothing, we would do something else. Okay? So you might recall that I said that this is implemented in JavaScript using the if-else statement, and in my explanation I said that unlike the one-way decision structure where we would do nothing along the false path, with the two-way decision structure we do something significant if it evaluates true, and we do something else significant if it evaluates false. So we have a meaningful false path in a two-way decision structure. And in this example, I would evaluate the Fahrenheit value, and if it's less than or equal to 32, I would display, assign to my display element the string value cold and color it blue. Otherwise, I would assign to my display element not cold and assign a string value of green, or a color of green. Okay, so I'll do one or the other, and then as before, once I've completed the true path or the false path, then the logic structure ends at this point right here where the two paths merge, and at this point then I'm done with whatever I need to do. But instead of stopping, in some other instances I might continue on. So I don't want to leave you with the impression that once you complete a flow of control structure that you have to terminate the algorithm, or you have to terminate the program. It's just that once you have completed the control of flow structure, in this case I'm stopping, but otherwise you would just continue on with whatever else needs to be done independent of that control structure. All right, so that's the simple one-way and two-way decision logic. We're going to take a look at something else here in a moment, and that something else is the nested decision logic. Okay, so if you have had experience, working with spreadsheets, for instance, you may be familiar with the if function, and you may be familiar with the idea that you can put a function inside of a function. I can put an if function inside of an if function and create more complex logic structures. And so I can do the same thing with an imperative programming language. And in this case, what if I want to do something if it evaluates true, and if it evaluates false, I want to make a further decision and then do something based on that further decision. That's what this kind of logic is all about. So if you'll follow me here with the nested decision logic, again, we'll have a chance to see this in program code, but if you can understand the logic up front by way of these flowcharts, it's going to make life a lot easier. In this case, what I do is I begin the process, I get the Celsius value, I do the calculation. First 3 steps are the same as before. When I reach this point right here, I'm looking at a decision point associated with a two-way decision structure. In the event that the calculated value is less than or equal to 32, it would take the true path and do the normal thing, display cold and change the back color, and then it's done. That's the point where the decision structure, the entire decision structure, ends. So the true path is fairly simple. If it evaluates true, does a couple of things, and then it is done with the entire decision structure. On the other hand, if the value is not less than 32, then it would take the false path, and the false path would lead to a nested or a decision structure that's embedded within this first decision structure. And that embedded or nested decision structure, in this case, happens to be, again, a two-way decision. Now, it wouldn't have to be. It could be a one-way decision nested within a two-way decision structure. I mean, we can mix these up as we need to in order to solve the problem. And we can also nest as deeply as we want to go. So I could have a decision structure inside of a decision structure, inside of a decision structure, inside of a decision structure. This can go on as many times as necessary. But in this case, if I get my input and calculate the Fahrenheit value and determine that the calculated Fahrenheit value is not less than 32 degrees, it's going to take the false path, and the false path is going to take it to another nested decision point where it's going to check to see whether or not the calculated value is less than 100. If it is less than 100, it will take the true path and display moderate, and then that structure will end, which will eventually lead to the end of the overall structure. If the Fahrenheit value is not less than 100, then it takes the false path and displays something else. And again, if it takes the false path, then this nested decision ends at this point, and when it ends, the path takes you to the end of the outer structure. So hopefully that makes sense. And again, I'm using flowcharts here to describe the process. All right, let's flip over and take a look at the JavaScript code.